In my latest project for a cab ride company similar to Uber, I conducted an exciting A/B test on a groundbreaking feature to be launched on their mobile app. This feature will analyze your driver ratings, reviews, availability, and proximity to your location to predict the best match ride for you. Imagine getting matched with the perfect driver every time. So stay tuned to discover how I used A/B testing to uncover insights on whether this feature should be rolled out to the public or not. In this video, we'll be covering the following. We'll be looking at the objective of this analysis, the methodology used, the results, the decision, and conclusion and recommendation. Then finally, at the end of this video, I'll be walking you through my Python script to see how I went about this analysis in full. Now we are going into the objective of this analysis. Remember, as I stated earlier, that this cab company developed this new feature for their mobile app where they can predict the best match ride for you based on some certain metrics. And it's our job now as analysts to test this feature. You know, companies don't just roll out features on their app or website or anything. They have to test it out and see how it impacts some metrics they measure. So in this case, we are testing this feature out to see how it will affect the user retention rate and the satisfaction rate. These the two main metrics we'll be testing out in the case of this analysis. Now we'll be moving into the methodology for this analysis, and I've grouped it into three: the experimental design, the success metrics, and the hypothesis. Now, in this analysis, under the experimental design, in this analysis, the users we are grouped into two. It's either they are part of the control group. This group did not receive this new feature in their mobile app, or the test group, the group that we are using for the beta test, they received this new feature and they are making use of it. The alpha for this analysis was placed at 5%, the statistical power at 80%, and statistical power, what it does is that it's the probability of detecting an effect if this effect truly exists, and it's used also to calculate the sample size we'll be using for this analysis. The minimum detectable effect, which is the MDE, was placed at 5%. If we are a company that has a large market value like Uber, the MDE would have been something like 1%, because a 1% change in their metrics would actually mean a lot in terms of revenue, customer satisfaction, and retention. But this company don't have that large market share, so we are using an MDE of 5%. The success metrics for this analysis is the user retention rate and the user satisfaction rate. These are the two metrics they intend to target for the sake of this analysis. And the hypothesis for the user retention, the null hypothesis states that this new feature does not affect the user retention rate, while for the satisfaction rate, the null hypothesis states that this new feature does not affect the satisfaction rate. We know that the alternative hypothesis will state the opposite. That's why it's not included here in the slide. After our initial analysis, the following results were gotten. For the retention rate, we discovered that the control group had a retention rate of 89.52%, while that of the test group was 90.13%. And we can see that the treatment group, that's the test group, performed better than our control group with a lift of 0.7%. Lift is the percentage increase or decrease in our metrics as a result of implementing a new feature. And we know that the new feature in our case here is the feature that helps users predict their best match ride. Based on the results of the satisfaction rate, we discovered that the control group performed better than the test group The control group had a satisfaction rate of 20.13%, while the test group had a satisfaction rate of 19.41%, which generated a lift of about negative 3.6, showing that the control group performed significantly better than the test group. And in the course of this video, we're going to find out how and why. The next thing we have to do is to perform a test of significance. So we have to test this our result to see if the outcome is statistically significant or just due to a random chance. And we'll be doing that using the t-test. So for the retention rate, we discovered that it had a p-value of 0.216, which is greater than our alpha of 0.05. Thus, we are rejecting the null hypothesis and conclude that this new feature has an effect on retention rate. Also, the satisfaction rate had a p-value of 0.3234, which is also greater than our alpha of 0.05. Thus, we also reject the null hypothesis and conclude that this new feature, has an effect on satisfaction rate. Having gone through this analysis and tested it for significance, it's now time to reach a decision. We have to decide on if this product should be launched and if it should not be launched. And from our analysis, we strongly advise the project manager not to roll out this feature to the whole public yet, because this feature has not been fully optimized to achieve a better result. Yes, in isolation, the feature may work, but when testing it against key metrics which affect the whole business, we found out that this feature is not yet ready to be rolled out to the public yet. In line with the analysis, the following recommendations were made. Firstly, we strongly advise that this new feature should be worked on to improve its whole efficiency by including some key metrics like average response time, average arrival time. This is done to protect the users from delayed rides, which can affect their satisfaction score, as we saw in the analysis. Also, the overall efficiency of this app should be monitored to ensure there is no other reason why users are not having a wonderful experience using these services. Next, we'll be diving into the Python script. Stay tuned. Finally, I'll be taking you through a quick rundown of the Python script. This will just be a quick rundown of this script. I will provide the link to my GitHub and you can study the code there. So first of all, we have to import the necessary package, import our file, that's the data set, and it's a CSV file on my local computer. So I have to import it, merge it by a common column, which is the user ID, then perform some data cleaning and pre-processing. So I have to remove some columns that are not necessary, find a way to deal with the null values, remove duplicate data. So we remove the duplicate data in our ride ID because that's the key column in this analysis. There can be multiple ride ID from the same user ID, showing that this user keep on making use of this our mobile app for booking of rides. So the key ID here now is the ride ID because there can't be two ride ID. So it's the key ID. Make sure there is no duplicate in it. Confirm there is no duplicate in the column. So it says ride ID X because when we merged the data set, there was ride ID X, ride ID Y, which is the same thing, but due to we performed an inner join, due to we performed an outer join, it picked it up too and renamed it X and Y. So we had to delete the ride ID Y, here. So making ride ID X our key column here now. So we confirm there is no duplicate in it. Got the total number of ride IDs. So this data set has a total unique ride ID of 1,661 161,363, sorry about that, unique rights that were booked within this 30-day period this analysis was performed. So we checked for null values. We discovered that we still have null values in the ride rating, ride review, open apps, booking. So first of all, I have to deal with some columns I won't be needing. Furthermore, this ride ID, distance, duration, fare, the review, because I already have the ratings which I need mainly for this analysis. So after that, I now cleaned up to take care of this null value is present. I cleaned it up further, took care of it, merged the dataset completely now, and we went further into the EDA and visualization of the dataset to see the distribution of the data we have there. So as you can see, we have more control. We have more data in the control group than in the test group, but it doesn't matter actually, because when we'll be performing this analysis, we just pick 10,000 data by random sampling. So this is just like the population. When it's time to pick the actual sample size, it doesn't really matter because we will pick an equal sample size from both groups. So this is the count for the control group, the count for the test group. So I also performed more analysis on it. Count of rides for the true match and count of rides for the false match. So this should be count of ride ratings for the true match and false match. So the true match shows the users that actually receive this feature, that are actually part of this beta test. They receive this feature and they actually made use of this feature to book their rights, and the false shows that they actually got this feature but they did not make use of it. So on average, we see that we are getting almost pretty the same ride rating for both groups. Count of match prediction. So it shows the true match and the false match, and we have the same number of participants in both. So after that, I entered straight into the A/B testing. Now in this A/B testing, we are using a booking threshold of 4 because we are looking at users that make use of this ride repeatedly, on average of like 4 times within the month, unlike just using 2 times, showing that they repeated the ride. But we want to make sure we capture core users, and we are using a threshold of 4 to determine the core users. Now from this analysis, we can see that the control group and the test group have a different retention rates, where the test group performed better, as shown in the slide we saw previously. We also calculated that of the satisfaction rate and much more, before finally calculating the lift between these two metrics. So the lift for the user retention rate was 0.067, and that of the satisfaction rate is negative 0.053, as we saw in the slide. Now after this, I moved straight into the hypothesis testing. I stated the hypothesis for the user retention rate and that for the satisfaction rate before moving into my test for significance. In the slides, I used the t-test for the analysis also, but here I also have the chi-square test also, so that I could compare and see that everything is in line. So after the test of significance, it's now finally time to interpret the results, and this is the interpretation and decision, the conclusion, and final recommendation to the product manager. Remember, I said that this is just a quick rundown of the code, that I will be linking my GitHub in the description below so that you can actually go through this code, study it, and let me know in the comment section what you think. So that will be all for this quick rundown. Thank you so much for watching. I would like to know your suggestions on how to make this project series better or on this project in the comment section below. Tell me what you think about this project, how it could be made better, what I missed out, what I could have added, and overall how I can make this project series much better. Thank you so much for watching. And if you enjoyed this video, please do like and subscribe to my channel. Next on our project series, we'll be building a lead prediction and scoring model. So we'll be building a model that can actually predict leads and score them by their likelihood to convert. Stay tuned, that's what we'll be doing next. And you can connect with me on LinkedIn using the link in the description. Sorry about that. Using the link in the description. Thanks for watching once more.